filled in some gaps. I don't know if the gaps need to be filled in, but I enjoyed the movie. All right, so we have to row reduce A, B, C, D down to 1, 0, 0, 1. So that'll be fun. In order to do so, it's kind of good that we did the example that came before it, because getting a 9 to cancel a negative, getting a 9 to cancel a 7 is kind of the framework that we need in order to get the A to cancel the C. Okay, so I need the A to become a 1, and I want the opposite of C. So if I'm going to basically make A into the opposite of C, I need A to go away, division, and I need to introduce a negative C, so multiplication, negative C over A. Right? That's going to create an algebraic expression that maybe you're not too thrilled with, but it'll be fun. So I'll have 0. I have the D that's already there, but I'm going to add to that negative BC over A. So I'm going to do negative BC over A plus the D that's already there. Then I'm taking the negative C over A, multiplying it by 1 and adding it to 0. So negative C over A. And then I'll get a 1 as a result for the last one, because anything times 0 is 0. Plus 1 is 1. All right. Nice, or maybe not nice, but a useful intermediate step would be to get yourself a common denominator. 0 is fine. This would become, multiply top and bottom of this by A, negative BC plus AD. How about AD minus BC? Over A. All right, so it feels right. Feels like we're doing something right, because that's part of our formula. Having A's, A, B, C's, and D's, that's expected, but having that actual subtraction in there makes it indicative of something positive that's happening. All right. Now that second entry in row 2 needs to become a 1. All right. So I need to take my entire row 2 and multiply by the reciprocal of that. So if I multiply this negative C over A by this expression, the A's are going to cancel. I'll be left with a C, and that's lovely denominator. So negative C over AD minus BC. And then the last entry, A over AD minus BC. All right. Now, we do know what the answer is supposed to be. It's supposed to be 1 over AD minus BC multiplied by a matrix. All right, so, as ugly as this looks, we're moving in the right direction, because at some point, I'm going to have to be able to factor out a scalar multiple of 1 over AD minus BC. Which means that at some point, one or both of these, I mean, if it has a 0, it has a 0, but one or both of these are going to have to contain a denominator of AD minus BC. So we're stepping in the right direction here. I want the B in the top row to go away. So negative B R2 plus R1. All right, so I'll work right to left. It's really just taking those two mega fractions in the bottom, multiplying them by negative b, so introducing a negative b to the numerator and just adding them to the top. So negative, oh, green. Negative AB over AD minus BC. The next one is a little not as nice because I have to multiply the negative C by negative B, so that'll be a BC over this denominator, but then I have to add it to the 1. That's the part that's not as nice, but it'll clean up, which is kind of good. All right, so I'm going to have 1 plus BC over AD minus BC. Then we'll have the 0 that we intended to get when we multiply by negative b, and the a. Bottom row remains as is. All right, let's get another equality matrix going here, because I want to put these two guys together and make one single fraction instead of the mess that it is. So I'm not going to perform any operations. I'm just going to clean it up. If I get a common denominator, the 1 becomes AD minus BC over AD minus BC. So I'll have a negative BC up top plus a BC. It's going to cancel. So I'm going to have AD over AD minus BC. And again, keep an eye on the situation. You know what you're looking for. You're looking for this. My mission of having all my denominators contain an AD minus BC is accomplished. That A's got to become a 1. So row 1 should get divided by an A. So 1 over A, row 1. Then we're pretty much there. So 1, 0, D over AD minus BC, negative B over AD minus BC, 0, 1, we have negative C over AD minus BC, and A over AD minus BC. All right, so this whole shebang here is the inverse of A, matrix A. Now, they do have a common scalar, so I can factor it out. Inverse of A would be 1 over, so I'll pull that out, AD minus BC. And what's left? The D, the negative B, the negative C, and the A. Crikey. Thank you. I was so triumphant too. It's like the worst. And possibly somebody to think for me too. So yeah, at some point somebody actually went into this process with no expectation whatsoever. So that would be the derivation, the generation of the formula that we just proved. Right? We proved that it's true based off of an expectation of an outcome, but somebody at some point had no idea what the outcome was going to be and was just hoping. And in the hoping process led to this result. So I think that's pretty cool stuff.